We have invested in upgrading our 3D printers in the last few years, and we are now boasting a Mark-forged Mark II for continuous fibre reinforcement CFR printing. It has a 320 by 130 by 150 mm build volume and uses microcarbon filled nylon, onyx, or CFR with onyx and carbon, Kevlar or glass fibre reinforcement. For our larger 3D printing, we have the Big Rep Studio G2, which has a build volume of 1000 by 500 by 500 mm and uses a range of print materials including PLA, ABS and carbon fibre reinforced filament. This is used when it is more challenging to join smaller prints to form the larger component. Our third 3D printer is the Stratasys F170, which is used for many of the student projects. It has a 254 mm cube build volume and uses predominantly PLA and ABS materials. The 3D printers offer flexibility and increased capability for design and innovation in student projects. Next to the metrology lab. In our metrology lab, we have a digital microscope, which is used for a number of applications, including composite material void checking. One of our main pieces of metrology equipment is the Mitutoyo Coordinate Measuring Machine, the CMM. This is a contact measuring system which we use for verifying component dimensions and for reverse engineering of components. Projects involving the use of the coordinate measuring machine include accurately dimensioning curling stones to produce engineering drawings and specifications for their manufacture. Other projects have involved dimension testing for medical device implants. For non-contact, we have the Quick Vision Dimensional Accuracy System, which is used for magnified specimen inspection and size analysis where contact is not possible. Now we'll have a look at our workshop machining and fabrication area. The workshop and machining and fabrication area provides a traditional engineering workshop. Students get familiarised in this environment throughout their studies while undertaking standard laboratories, and they have to comply to appropriate health and safety requirements within this area. The equipment in the workshop includes lathes, milling machines, sheet metal forming and assembly. This equipment is used to produce the majority of engineering components in a variety of materials. Students are exposed to this during their workshop familiarisation tour in their first term in Year 1. Final year projects requiring components for testing will also utilise this space and equipment to produce the required components. An overview of some more of the machining and manufacturing equipment is now being presented. In addition to the manual machining equipment, we have a 3 and 5 axis CNC capability. Strain gauging. Strain gauging is undertaken on multiple materials by trained technicians and is demonstrated to students during composite laboratories or, if required, during final year projects. Multiple strain gauges or strain gauge rosettes are applied to different materials as appropriate. Materials destructive testing. The calibrated 50 and 100 kN Instron universal testing machines are used for tension, compression, bending, interlaminar shear and compression after impact testing. The video extensometer is used for strain measuring, complementing the strain gauging capability. All are instrumented through either Instron's dedicated software or standalone data loggers. The 2 meganewton ESH universal tester is used where loads will exceed the Instron 100 kN capacity. We have a welding area. The welding area is used for MIG and TIG welding to support the manufacture of test equipment or test pieces. Now to our wind tunnel. The subsonic 0.5 metre squared working section wind tunnel is used for a number of laboratories throughout the programmes and in final year project work, providing the ability to measure force and pressure distribution. The composite room. This room is used to manufacture composite specimens, including glass, carbon, or Kevlar and epoxy resin, either at room temperature or within the Cure Cycle controlled oven. The oven has internal dimensions of 1070 by 430 by 500 millimeters. A number of student projects utilise this area to produce the test specimens prior to testing. The Materials Laboratory. The Materials Laboratory is used for microscopy examination and hardness testing. Nano-hardness is also available for materials characterization. In the Practical Laboratory is the space where the majority of the student laboratory equipment is located, and the activity covers all years from 1 to 5 and includes equipment for linear air tracks for conservation of momentum demonstration, simple harmonic motion experiment, centroids experiment, beam bending experiment, buckling experiment, thick-walled cylinder experiment, forced, damped, undamped vibration experiment, torsional vibration experiment, and finally fatigue test experiment.